This session is really not a developer session per se. We're not going to talk so much about code or anything, but we're going to set the stage on the importance of why you need to write secure code and why you need to think about security being a developer. And I think that is becoming increasingly important. So we're going to talk about that a little bit. And the reason I'm on stage is because I work for this company called TrueSec, and my role there is being the manager of a team of consultants doing penetration testing, so we full-time break into systems. We find vulnerabilities in code so that we can compromise entire platforms and eventually entire corporations and government agencies. We do incident response, so whenever someone is compromised, we will be there understanding what happened and try to investigate and find out what can be done to limit the damage and so forth. So with that said, I'm going to try to share some of that experience and make you understand the importance of being a security practicing coder, if you will. And this session there's not going to be any PowerPoints, this is just going to be a live session. I'm going to show you some small paper or some small things from the papers. Apart from that, it's going to be one live demo, the whole thing. So I'm basically going to attack a platform, compromise an entire environment just because of one small vulnerability in code to show the importance of what you do. So just some examples of corporations being hacked so that you understand the impact today. Nasdaq, you ever heard about Nasdaq? This is when you nod your head and pretend you're listening, okay? Heard about Nasdaq? Yeah, hell yeah, they're talking. Nice, it speaks. So, this is actually an attack from 2011. But it's kind of interesting. This is from Bloomberg magazine. And you can read some statements here from FBI. One is, our assumption was, generally speaking, the financial sector had its act together much more. They were really surprised. This is a guy from the White House. They were really surprised that it was so easy to break into Nasdaq. Not because Nasdaq is worse than everybody else, but you have this assumption that they must be really good, they're Nasdaq. But like all the others, they focus on implementing features, not necessarily on making sure everything is secure. And I guess you can recognize that. I mean, you have all these feature sets. How much focus is there on security when you develop things and when you build stuff? And what will be the impact? Well, agents found the tracks of several different groups operating freely inside the Nasdaq servers. Okay? Some of which may have been in the exchange networks for years. Kind of scary, right? Including criminal hackers and Chinese cyber spies. Do you think it was fun to be the CIO when you read this? Not really, no. Not just Nasdaq, this is JP Morgan Chase, one of the largest banks in the world. This is from October last year. 76 million customer accounts exposed. Lots of more data than that, probably. No one will ever know what they really stole. They have to report this because this is about US citizens. Anthem, largest insurance company in the world, February this year. So this is going on all the time. And an interesting thing, me being stationed in Sweden, even though I work all over the world, we don't have a law in Sweden that tells people that they have to report intrusions. That law is coming. So as of right now, there's a lot of unknowns. I think 99% of the investigations I've been involved with have never ever gone to the police or ever being printed in the papers. So that's why I think it's necessary or important to share this. The economy behind it. Well, this is one example. This is a group of probably Ukrainian, Russian people. They break into banks. It's a simple methodology. They somehow send spam emails to bank employees. They install Trojans, and then they attack internal systems. The estimation is that they have got their hands on $1 billion in cash over these campaigns. They actually say somewhere between 300 and 1 billion. 300 million and 1 billion. And it's kind of interesting when you realize what you can do with computers. I mean, Many of the attacks have been just, compromising important systems internally and then transfer big sums of money. But they also do some more exotic things. For example, they attack the systems controlling the ATM machines of some specific brands, and they make them empty themselves in a certain amount of time in the middle of the night. So they have people standing there with plastic bags, and there can be like $1 million in one vending machine. So it's kind of worth it, even though it's not the most lucrative thing they do. It's pretty cool. I mean, when you realize it, if you can program a system, you can make it do anything, right? If you can really compromise it. So, what does an attack look like? How many of you guys have ever done like something similar to a penetration test or something? Break into a system? Lots of people. Cool. Why? Is that your job description, or is it just something you do because you're kind of... Okay. I was surprised. I usually speak to a lot of people, and I don't usually see such a big number of hands in the air. I hope that is within what you are supposed to be doing, not something else. Anyhow, so of course, if we're going to break into an environment, and I'm going to show you this in a way how it's usually done, there are some phases that you go through. Of course, like if you're going to rob a bank, there will be a stage before this all happens where you do surveillance and you try to map out what the facilities looks like, if there are guards and the routines and all that stuff. They will do the same thing when they target an environment. They will actually see who is working where, what rule do they have, what operating systems are they using, applications, anything they can get their hands on. Find email addresses, maybe Facebook IDs and stuff, so they can kind of get information from you before they attack. And I think it's kind of interesting when you think about it. Do you think a developer is more important today than it was a couple of years ago? I mean, there are many reasons for that. One is the fact that developers are developing important applications like web applications that are internet facing. Another thing is that the DevOps are sitting on clients and they are pushing code to various important systems themselves nowadays, also to the cloud. So if you really want to compromise this Amazon web service that you're subscribing to, maybe the developer is the best guy to hit. So it's becoming more and more important. The IT professionals are getting less important. You don't need complex internal networks, at least not in the future necessarily, because it will be cloud services. So developers and DevOps, I think that's the future, at least when you talk about numbers. There will always be exceptions. I think there will be legacy environments for 20, 30 more years. But the trend is changing. So step number one is to somehow compromise the first system, to break through the barrier. That would be either an internet-facing attack targeting a server or a client-side attack. Since I only have like 40 minutes, I'm going to focus on the server-side attack. What's important is the next step. Whenever you compromise one system, you will install a Trojans. You will actually turn it into an attack platform so that you can tunnel all the attacks from this guy. And he will probably have access rules to connect to some internal systems, like, for example, SQL servers. So that's called lateral movement. That's the next step. You're going to jump from computer to computer until you find the important credentials of, for example, a domain admin. And domain admins are the people that can authenticate and do whatever they want to the domain controllers. That is the ultimate goal in almost every attack we see out there. Because the domain controller, even though you have a lot of Unix systems or whatever, it will hold the credentials of every client and all the Windows platforms. And when you have the Windows clients, someone will log on from that client configuring the Unix system or that Amazon service or whatever. So you will get their credentials by sniffing keystrokes, stealing RSA keys and stuff like that. Microsoft Statistics, they have a pretty large incident response team, is that the time between the initial compromise, step number one, and the lateral movement until you compromise the entire domain is usually between 24 and 48 hours. Can you guess what the average time of from when you discover is? Can anyone guess? Hands in the air. Good. Months. Yeah, actually you're right. 18 to 24 months to be more specific. So usually they operate freely 1.5 to 2 years before they get discovered. There is an exception for the companies being robbed of like credit card numbers and stuff that usually get discovered earlier because there's so much money going away. Customers are reporting it. American Express get involved. They realize that that particular company had all those credit cards, so they will know they were attacked. They will hear about it. So, back to the demo. I am on the attack machine. The attack machine is red. So this is the attacker. I'm actually going to do this demo using free tools. So I'm not going to use any paid tools, even though we would normally use like more commercial grade tools in the office. So this will be Metasploit framework. I want to show it to you because I want you to know what you can do without any money and limited knowledge. Okay? So this is the attack platform right here. I have a web server. Being the attacker, I don't really know what it looks like. As right now, it looks like this to me. And this is from a real live case from my team. We just took the function that does file upload as an example and put it on this, its own web application, so it's going to be easy for you guys to follow. But this is typical. You need some place where an application accepts user input. And this is, of course, coded by bad security practices. There has to be a mistake made somewhere. I'm going to give you this as an example. One out of more than 1,000 examples we have from different pen tests. Okay? So I will just set the stage, make you think about the importance of writing secure code. You may be way smarter than this dude. So, this application was a file upload function, and you were supposed to upload your profile photo. This was actually a very, very important corporation. I can't go into details right now. So, since it's only allowed to upload photos, you can probably take a photo. I'm going to take this scary anonymous JPEG photo. Who knows? And of course, whenever there's a profile photo, it will display somewhere in the application. That's like the purpose of that upload, right? So you can see that face. So this is how it works. Nothing particular special. What do you want to upload if you're an attacker? What would be the ultimate thing to upload? This is obviously some ASPX file, so it's a .NET application. What would be the best thing for an attacker to upload? An executable would be amazing. What would be an executable from the perspective of a web server? It would be an ASPX file, right? Server-side execution, that's what you want. That's the ultimate goal. So good answer. If I had a chocolate bar, I'd give it to you. I don't this time, sorry. So, the typical thing you would want to upload would be something like this. This is a one-liner, C#. All it does, it instantiates cmd.exe. Whoa, this is Windows 8. Pretty cool and pretty annoying at the same time. I get that a lot when it comes to Windows. So anyhow, as you can see here, it will just run cmd. It will do the, oh my god, system diagnostics, process start info, and then cmd.exe. And it will redirect standard input and output to that HTML. That's basically what it does. So it's a one-liner. If you're old enough, you realize that back in the days, this would be C code and would be a pretty large, extensive set of code. So wouldn't it be nice if you could just, I mean, if this was a super lousy application, maybe you could just upload this, right? Open, upload this mini shell, and it says, of course, uploaded file is not an image. So something is checking whether or not this is an image. It could be just file extensions. We could try. So we could rename this to something.jpg. It somehow, from some standpoints, turns into a picture, depending on how smart the programmer was. Open, and then upload. But it still says uploaded file is not an image. So somehow he's checking whether or not this is an image for real. It could be metadata, it could be loading it as an image itself, or I don't really know what it's using right now, because I'm the attacker, I don't necessarily have the source code. So sometimes they could be checking for that and relying on that check so much they don't even care about file extensions. Because that's what happens sometimes. You don't have like different security features, you rely on one, for example, or one could be weak and one could be, or two could be weak for different reasons. So this is what the guy in my team did. He took the anonymous JPEG picture, he renamed it to jpeg.aspx. It was actually some more filtering going on, so he had to have JPEG in there, he had to do some special stuff. But basically it would let an ASPX file through. ASPX, so we renamed it and uploaded the anonymous picture again, now with the new file extension. And this is an image, right? So we uploaded it, and it says uploaded successfully. Interesting, as long as it's an image, it will be allowed upload, no matter the file extension. So this is the result. And if you look at this, it's kind of interesting. There seems to be some metadata in the beginning, right? And the rest is readable. This is how a modern IIS interprets an image when it tries to execute as if it was an ASPX file. It will print the readable characters, because regular characters are HTML. You're allowed to write just text. So how would you attack this? This is the first question an attacker would ask himself. How can I attack this? What if I could take that one-liner, the CMD shell, and put it somewhere in the beginning before it breaks to make it execute? That's what they would do in this particular case. Isn't it kind of cool if it works? This is when you nod or shake your head to give me some feedback. They nod their heads. I'm just telling this to the camera because this is a recorded session. They're nodding. They like it, I think, maybe. So anyhow, let's do another one just to show you the result. So back to this upload function. I'm going to browse. I think it's kind of, I don't have any patience. My mother used to tell me that's a bad thing, but it took me places. So anyhow, you recognize that, right? So I'm going to browse, and I'm going to do the TrueSec JPEG image. I'm just going to show you that it's still just an image. Upload this file. It's me and my colleague Hassan the Wolf Al-Shakarti. Maybe you can guess why it's called the Wolf. Well, it has something to do with Pulp Fiction as well. Anyhow, I'm going to go back, and I'm going to change some things about this. We're going to look at this picture right here. So this is a tool called the EXIF tool. It would just read and manipulate metadata on any picture. So I'm going to take this TrueSec JPEG and look at it from a metadata perspective. And some of this stuff is getting printed if I rename it to ASPX. So I know that this will be fed to the web application. This is text that will be read. So what if I could put the code in here? How hard can that be? And I am so fast on the keyboard. Can you see? Just wrote this. Cool, huh? So what I'm doing is I'm doing EXIF tool, and I'm putting a comment line in there containing the script, and I'm just injecting it to the TrueSec JPEG picture. So if I look at it again, it now has a comment field containing this information. So what do you think is going to happen when I upload it? And this is by design. This is how IIS and a modern Windows Server 2012 R2 will just do it. It's not really a vulnerability. It's read HTML. So let's see. This is when the magic begins. So let's rename it to ASPX. Not edit, rename. Damn. I'm getting old. Rename. JPEG.aspx. Hell yeah. Still a picture. Upload it. Upload. Isn't this kind of cool? I have this small thing here, so if I do an ipconfig, for example, I get the IP configuration on this system. Who am I? Obviously, I'm not a privileged user, I'm the Apple account, but I'm executing code on this platform. So this is typically what an attacker will do. So this is the importance of making a secure application. If you have one small vulnerability like this, it could lead to someone sitting on the internet attacking the web server and executing code on it. The next demo will be what I can do from here. And in many pen tests, we can take it from here to domain compromise. So, do you think this is a nice UI? You can actually say yes or no. You don't even have to nod your heads. You can just cry right out. Do you think this is a nice UI for an attacker? No. So let's make it nicer, right? So I have my Metasploit framework here, my attack platform. And this one is waiting for connections. So any compromised system that will phone home will register himself here. Okay? So looking at the map now, this is actually a red computer. It's compromised to some level. I have a limited account access, but I still have access. So I want him to phone home to my Metasploit platform so I can remotely control him. Phoning home is always better than connecting because outbound firewall rules are usually more relaxed than inbound firewall rules. So this is listening for connections. And I have this. I'm just going to show you how you do things nowadays when you attack stuff like this. I don't want to do too many things on the hard drive on that system because that may trigger an antivirus. So basically what I'm going to do is I'm going to send this string in. This is a PowerShell encoded command. It's just base64 encoded. It will basically tell this server to go to my web server, download a .NET function that will execute within PowerShell, and the .NET function will inject shellcode into RAM without really touching disk. So it's kind of sandboxed within the PowerShell process. So shellcode is being executed by .NET, which is being executed by PowerShell. But all I'm sending is this. I can explain that later. I don't have time for it right now. But if you really want to know what's going on, I'll show it to you in the break. The result is no antivirus today will find it. So this is how pen testers and hackers do it. PowerShell is getting increasingly popular. So it's a one-liner. And the way I can prove that this works, except for the fact that you're always nervous when you do live demos, is that I have this listener here. I'm just going to go back to the web application, and I'm going to inject this one-liner and run it and wait. You can do it. Come on. Oh, yeah. So my interpreter session 1 opened. So he phoned home because I sent that one string in. It actually does touch the disk, but that is PowerShell. Whenever you run .NET code, it will compile using a DLL, like a temporary DLL. But it's not going to look like a normal DLL, and it's not going to be checked by antivirus that way. So anyhow, I have a session 1 open. I can interact with it. So I just do sessions, interact with session 1. Now I'm in it. I can do a get your ID, see who I am. And I will for sure get the app pool account, because this is probably a modern Windows. That you can usually find out. I can get some system info, sysinfo. See what computer this is. Well, this is someone called DMZ100. It's a Windows 2012 R2. We haven't done anything to relax the functionality, but I'm executing code on it. And some people get confused, like they think that you can't do so much if you're not local admin or system account. You can do a lot. And maybe you react to the fact that, well, this is just his attack platform in this virtual environment. In the real world, I would have something like this. This is my attack platform running in Azure. So this is in mssecurecloudapp.net. So this is the same thing, Metasploit framework, but it runs in a Microsoft rented cloud space. So whenever the real compromise is going on, there will be just outbound SSL connections to Microsoft IP addresses in Microsoft Azure. I don't think your firewalls are going to be that scared. And even though I am personally on a Windows 8.1 or Windows 8 on this system, and I'm running in low privs, if I were to hack myself, I'm just going to run a Metasploit agent, just an example, you will see that I can do a lot of things. There's a session open now, session 2. And again, this is SSL, so it's encrypted. If I do a sessions, interact, I have this session 2. I can interact with session 2. Yes, you know how effective it is. Now you can think of yourself being the DevOps, and I run code on your system. For example, I could do a webcam stream. Why? I don't think a hacker would necessarily do this, but it's such a cool demo. So, well, it's a kind of slow line here, so come on, you can do it. Stream, please. It's way cooler when it works. Way more impressive. Way boring when it doesn't. Device is not ready. Have I hacked this too many times? I did show this yesterday. I hate to tell, well, you get the point. It's like, that's not what I want to do. Exit. Oh, wait. I'm so stubborn. That's one of my other bad and good personality disorders. So I usually try like 3-4 times before I give up. Well, for some reason it doesn't work, then I'll maybe get back to that later. But there are so many things you can do. If you look at the help file, just in Metasploit, you can do anything from stream a camera when it works. You can do key scans. You can actually take keystrokes. And that you can do as a regular user. And of course, you can upload and download files, go through the file system and stuff like that. So it's a very competent tool, even though this was a pretty annoying situation for me. Anyhow, so back to the real attack instead. So I'm on the interpreter. What I want to do now, this is a web server. Well, I want to do lateral movement. I want to connect to other system. If I were logged on as an admin, I could extract credentials, user credentials. So if there was an admin that has access to other servers, I could steal his keys. Because wherever you log on, you take the keys with you. But I'm just the Apple account. So normally you have two options. Either you start attacking internal servers by like brute forcing, guessing passwords and stuff, or you see if you can find something locally. So I can do this in different ways. So let's just do one example. I'm going to do a brute force attack on internal systems and just see if I can find some SQL servers, for example. So let's see. So many different cool things in my... Yeah, here. So I'm going to do this. I'm actually going to put some -n in there. I'm going to check the internal network to see if there are some SQL servers. I'm doing this from Metasploit. An important thing to understand in this tool is that there is a function in Metasploit called autoroute. And basically what autoroute does is that it sorry, we're going to do background. It will actually route all the traffic through this compromised web server. So I can now connect to internal networks through him. So looking at the result from this Nmap scan, I find that one SQL server is open. I'm looking for port 1433, the Microsoft SQL. So there is an open one on server 10.10.10.110. So now I can attack that one. And normally you can do a brute force attack. And this is one example out of hundreds of things I can do with something that most programmers can relate to, a SQL server, right? And of course, there could be lockouts and stuff, but I'm going to give you this as one example. So, back to the attack. I'm going to use a logon, and I'm going to connect to this 10.10.10.110. I'm going to use a password file that is just loaded with lots of potential passwords and run it. This is what they call a cut and paste attack. It's kind of convenient. This is actually how you do it at the office when you're a pen tester sometimes. You've done it so many times, you have all this prepared. You could call it scripts if you will, or whatever, which is just notepad clips. But you see, it will guess different passwords until it finds something that is valid. Yeah. So in this case, it says, login successful to this workstation using the SA account and a strong SA password. And I always joke when I find this one, because this is in the manual for installation of Microsoft SQL Server. It says, please enter a strong SA password. And I think in every 10th installation I find during pen test, they still have this password. Like, please enter a strong SA password. It's kind of lame. But of course, if it's guessable, it's guessable. Many times you actually find connection strings somewhere in some file on the web server. So you don't even have to guess. This is just an example. Or if it's integrated security, maybe the app pool account is allowed to connect to the SQL Server. But in this case, we have an old school SA logon, which is good. So I'm going to use this knowledge, the SA and password combination and this IP address to connect to the SQL Server. And I can do this in different ways. I'm actually going to use a fairly modern way. I'm going to do the same thing I did seconds ago, targeting the web server. I'm going to run this PowerShell encoded command so that I don't touch disk more than necessary and no antivirus will detect it. So I'm just going to say, use the SQL execution command function in Metasploit, send in this PowerShell encoded string, and connect using these credentials. So all of a sudden, this small file upload vulnerability is turning into a door for an attacker to compromise an internal SQL server. That's kind of interesting, isn't it? So interpreter session 2 opened. And when you do a real attack, after a while, you will have a large list of compromised systems. So you can jump and enter any one of them as you please. So this is the web server. This number 2 is the server 110 internally. So I can interact with this guy and see who I am now, get UID. And this is interesting because this will be probably an account running in higher credentials, higher privs. Because this is an internal SQL server. Nobody cares. They just wanted to be able to do anything it's supposed to be doing. It's internal. So this is running in system credentials. Very common still today. The web application dude who coded the web app, he didn't worry about what the credentials would be on the SQL server. So he couldn't estimate the impact. And the SQL dude could never, ever foresee that someone would code a weak application to expose his internal SQL server. So this is the disconnect, right? So take it from here. We're now on this system. Get your sysinfo. Windows Server 2012. I'm going to do PS to see what processes are running. And this is interesting because there is not just internal accounts, It's something, a domain account from the @RIP domain, and it's called Ming DADM. This is one of the accounts running processes on this server. So a DADM tells me this could potentially be a domain admin. They usually have something, A accounts or something. And again, I only have 40 minutes, so I'm going to be very lucky. The domain admin is logged onto this very server. Normally I would have to jump from server to server until I find one of these. So because of time constraints, it's going to take me 40 minutes to compromise the domain. Normally it would take an hour more. Who knows? So, what can I do from here? Well, I'm going to do a quick password extraction. Actually, I'm going to have to inject myself into the LSAS process, because the LSAS process is allowed to steal secrets from the system. So I will go into this process, LSAS, which is running in process ID 508. So there is, of course, a function built into Metasploit that says migrate. So I can migrate into 508. This is convenient. So I can become the LSAS process. So I will have the authority to steal secrets. So this is how they do it. So now this small upload problem will allow me to steal password credentials of an internal SQL server. So just to save some time, I put some tools in there. This can be done directly from Metasploit framework, but it's kind of shaky, not so stable. So I'm going to do this using a tool called Mimikatz. Mimikatz is a free-to-download tool that will steal password hashes and other secrets from systems. So this is what you get when you run the Mimikatz command. You will get NTLM, or MT hashes actually, of different accounts. This is a computer account. I am the computer already, so I don't need him. But I'm going to look to see where I can find that DADM account. And here he is, the Ming DADM. And his keys are here. This is the MT hash. And the hash is a representation of the password that can be used directly to authenticate to other systems. You don't have to crack it and turn it into clear text. So my next step will be to use this key that is exposed on the SQL server to connect to the domain controller. So back to the diagram. I'm not here anymore. I'm here. I have compromised the SQL server. And I now have, I've done this, I did lateral movement. Now I have the credentials of the domain account that potentially can log on to the server, domain controller. So let's see if that works. Let's see if I can connect. And for some reason, I think I'm going to be successful. I don't know. Could I have done this before? Who knows? Could I have pre-cooked this demo? Who knows? But is it a valid case? Absolutely. So if I really want to find out what the domain controller, where it's located, I can ping the domain, ping @rip.internal. It says @rip.internal here, so it's easy to guess. And I will see that 10, 10, 10, 100, that's the domain controller, so I can always find the systems. I'm in the domain. So let's see if I can connect to him. Exit. And I'm going to background this process. And then I'm going to do run this connection. No, that's not what I'm running. Ah, good. That was just the password hash. So I'm going to do connection using SMB to the 100 server with the Ming DADM and actually the password hash that I inject here. This is the LM hash. It's not used on modern systems, so I can just blank it with zeros. Paste. Exploit. It says failed, but I think if I do it once or twice, it's actually going to work. This is kind of unstable. I don't know why. I'm going to give it some seconds to time out, and I'm going to run it again. It usually runs the second time. Don't ask me. I didn't write Metasploit framework, and it is for free. You know what? When you get free code, it's not always the best. It's not going to help when I double click, but and next time I do it, it usually works. Strange. Runtime error added. Yeah, right. Paste. Funny, huh? Experienced demo devil. So I have a session 3 opened. I'm actually in the session already. I can do a sysinfo. Sysinfo. And this is the server 100, so this is the domain controller. What do I want to do now? I'm going to do this super fast. I want to become the LSAS process on the domain controller, which is 512. So I'm going to migrate it into 512. 512. And then I'm going to do a hash dump. I'm going to dump all the hashes of the domain database. And using the same technique as I did before, I can impersonate anyone in the entire domain, become any account, read people's emails as if I was them, read their files as if I was them. So in the logs, it will just be Peter logging on to his resources. Hash dump. So this is the Active Directory database. If this was a real enterprise, of course, I would have hundreds or thousands or tens of thousands of users and computer accounts. I could become anyone. So this is the impact. I now compromise this one. I have the database. The domain controller is allowed to install code on any system using group policies. He holds all the accounts. So this is the issue right here. These small problems that you have can lead to domain compromise. This is what I see when I do this job. And I think I'm setting the stage for this day. So in upcoming sessions, we're going to talk about web application security, problems, best practices, other best practices when it comes to coding and security. So I think it's a break now. Did you enjoy the session? Good. Thank you so much for attending. See you soon. Thanks.